Welcome to Point channel. So today I will discuss about SpringBoot asynchronous communication concepts. So in this video I will cover like what is synchronous communication and what is asynchronous communication and the types of asynchronous communication and the real-time scenarios for this asynchronous communication and how to enable the asynchronous communication in SpringBoot application and key points to remember about this asynchronous communication and does @async execute in new thread each and every invocation? So that also I'm going to answer, and how to attach a thread pull to @async, and how to handle the exceptions in @async method. So all these concepts I'm going to cover. Okay, yeah. So first of all, what is synchronous communication? Okay, so so this is a type of communication where you expect a response to your request instantly. So that means you are a client, you just hit one request and immediately you are expecting a response from your server. So this type of communication is known as synchronous communication. Okay, and sometimes what happens, your server may take a bit a longer time than usual. Okay, so even in that case also what happens, your main thread has to wait until your long running execution finishes. Okay, so there is no other way, so so this is kind of a blocked way of communication. So that means you filed a request. Okay, let's assume you are having a main thread. Okay, now you want to execute process 1, process 2, process 3. So process 1 takes 10 seconds, process 2 takes 20 seconds, process 3 takes 30 seconds. So then 10 plus 20 plus 30, so total 60 seconds. So there is no other way. So main thread has to wait until it finishes process 1 for 10 seconds, and process 2 for 20 seconds, and process 3 for 30 seconds, and finally it will return the response back to the client. Until then, client has to wait. So this is a way of synchronous communication. Okay, so yeah, examples you can think like a phone call conversation or live chat. So all these scenarios comes under the synchronous communication. Okay, next, what is asynchronous communication? Asynchronous communication here, um, in this type of communication where you don't expect a response to your request instantly. Okay, so before hitting a request itself, that request may take a bit longer time. You already know. So okay, so and you are well prepared not to expect the response instantly. Okay, so in that case, what happens? As soon as you hit the request, okay, your main thread, okay, it will it will kick off that long running execution in a separate thread, in a new thread. So a new thread, and the main thread will proceed further, and it immediately it will return the response back to the client. So then the client will say, I mean, client will come to know, okay, saying, okay, server has accepted the request, and something request is in process or something like that. It will return the response back to the client. And the actual long running execution will be executed with a new thread in a background thread pool. Okay, in a background, you can say. Okay, so that's why it is known as a non-blocked way of programming. So the benefits of this asynchronous communication is, as I said in my previous example, okay, your main thread has to execute process 1, process 2, process 3, right? So for example, okay, since it takes more time to execute all three processes, okay, so for example, if you treat all these three processes as a asynchronous methods, okay, so then, okay, then in that case, okay, your your main method, okay, there are two possibilities. Either your main method will simply return the response back to the client if those methods are does not return anything. Okay, and the second possibility is, if they return a response, then main thread has to collect the response from those methods. Of course not 60 seconds. Why? Because all these three processes will run in parallel with new threads, right? So that's the benefit of asynchronous communication, right? So yeah, so types of asynchronous communication, as I said just now, there are two types of asynchronous communication. Okay, if your asynchronous method uh, with return type, okay, so if the method has a return type, we must wrap it with the completable future or future. Okay, this is a requirement if you like to use asynchronous service mode. Okay, so I think okay, you are running one long running execution, and finally you want to return the result back to the main thread. So in that case, this is one possibility. Okay, and the second possibility is method with void return. Okay, so your long running execution method, okay, it doesn't want to return the result back to the main thread or that previous caller method. Okay, so then in that case, I mean, the return type of that particular method will be void. Okay, so these are the two types of asynchronous communication. Okay, and real time scenarios for asynchronous communication. Okay, so in most of the projects, okay, we will come across this asynchronous communication. Okay, something like this. Okay, the first scenario, if you see here, when we fire a request which takes longer time than usual, okay, then it simply returns 202 status code, which is nothing but accepted. Okay, and a link to check the response. Okay, after some time. So what it returns immediately, two it will return the status code as a 202. Okay, and it will return some link. Okay, saying that okay, you can cross check the response by clicking on this particular link after some time or after a few seconds or something like that. Okay, and in the background immediately it will kick off that long running execution in a new thread. Okay, so that will it will continue the execution in a new thread. Okay, for some time. Okay, but client will never wait until that execution will finishes, right? Client will immediately get the response from the server saying that okay, boss, I have accepted your request. Okay, this is acknowledgement, and you will find your response at so and so location. This is your location. I mean, it will give some link. Okay, so this is a so this is one real time scenario. Okay, so so that particular link. Okay, so I mean, users or upstream systems or whoever files these particular requests. Okay, so they will continuously click on that particular response. Okay, like for every 2 seconds or something like that, until it sees the response as 200 instead of 202. If it sees the 200, then it's good to see the results. Okay, this is one type of scenario, and the second type of scenario is, for example, you are you know you are doing some kind of batch processing. Okay, each batch has so many, okay, internal okay internal requests. Like one batch has some 20 requests, one batch has 40 requests or something like that. Okay, so now, like you have some your core engine application, okay, where so many other applications or other upstream systems used to find your core engine application to get some response from that core engine by doing some processing. Okay, now at the end of this batch execution, okay, it wants to invoke some kind of callback URL. Callback URL is nothing but that upstream systems URL. Okay, so application 1 has filed one callback URL, application 2, similar application 3. So now what happens at the end of this batch execution? We used to invoke this callback URL with the help of this post call. Okay, post call. So that there is nothing post call. So we will drop the payload, payload, and invoke that post call. Okay, so then what happens? So our batch execution results will be will be posted to that upstream systems, that is application 1 or application 2, application 3, whoever continuously fights the request to the your core engine. Okay, so then I mean, see, this is kind of a low priority, so that's why obviously it takes a bit time. So we used to execute this type of callback functions with the help of this synchronous communication. Okay, and one more real-time scenario, at the end of request processing, suppose if you want to send out a mail to the user with the status of the request processing. Okay, so that type of execution also you can include within this asynchronous methodology. Okay. So why? Because you can immediately return the response back to the client. Okay, maybe after 2 seconds, after 5 seconds, client will receive a email saying that okay, your the request processing is done. These are the results or something like that. Okay. So these are the real-time scenarios. Okay. Now how to enable async communication in Spring Boot. Okay, now to enable the asynchronous communication or asynchronous processing, we need to do two things. The number one, we need to add @enable async annotation to the configuration class. So this configuration class could be your main class in which it is annotated with Spring Boot application, or you can have one more exclusive configuration, which is annotated with configuration. Anywhere you can add this @enable async. Okay. The next one, point number two, we need to add @async annotation to the method, okay, where we like to enable the asynchronous processing in a separate thread. Okay, for example, you have some piece of code which takes a more time to execute. Okay, then that type of methods, okay, you can annotate with @async. Okay, so then immediately it will try to execute that whole piece of code in a new thread. Okay, now, so these are the two important points. Okay, the third point. So as soon as you add @enable async, okay, then what happens internally? This annotation switches on Spring's ability to run your @async methods in a background thread pool. Okay, in a background thread pool, in the sense in a separate new thread. Okay, so, and by default this @enable async annotation detects your Spring's methods which are annotated with @async annotation. Okay, it will automatically detect, okay, in so and so class so and so method is annotated with @async, so I need to execute this piece of code in a new thread, like that @enable async will come to know. Okay, so yeah, uh, so now, okay, we will discuss the remaining slides. Okay, after a while. Okay, so now, so yeah, so now let's jump into the coding part. Okay, so now in order to demonstrate this asynchronous communication, okay, sometime before I have created a demo project. Okay, so I will walk through the code. Okay, so here if you see, this is the pom.xml, nothing fancy. So I just added the regular dependencies of Spring Boot: starter web, starter data GPA, starter test, Lombok dev tools. Okay, these are all MySQL. Okay, regular dependencies, nothing fancy. Okay, so here this is just a configuration. I will discuss on this. Okay, so here if you see, this is a controller. Okay, so in this controller, I have two methods. Okay, so to create an employee object in a synchronous way. Okay, and I want to calculate employees EPF, calculation like PF amount, pension amount in a synchronous way, and as well as a synchronous way. Okay, and this is to fetch an employee object from the database. That's it. That's it. Only three methods are there. Okay, so here these two are okay, so this plus, I mean, this is not required. This is additionally I just added. This is a POSO. Okay, so this is a employee. So this one I am going to utilize for this particular demo. Okay, so here if you see, this is a customized error response. Okay, so this is kind of a global exception handler. Wherever any exception throws in your Spring Boot application, obviously flow come to here, right? So this is just a global exception handler. Okay, and this is just a resource not found exception. I guess I'm not going to utilize this one also. Okay, I just added something just like that. So here, if you see, these are the just modals. Modal, right? Whenever we fire a request in the controller, I mean, we will receive the request in the form of this particular DTO object. Okay, this is for donor. Okay, this is for employee DTO. Okay, now our focus is only on employee, not on the other POSO. Okay. So here, we have some name, is salary. Here you can see city, PF amount, pension amount, and status code and status. Okay. So here, I mean, these are the two repositories. Okay. So, okay, we have some service class. Okay. So here, here if you see synchronous communication, asynchronous communication. Okay, the general create method and fetch employee. I will cover all these things. Okay. Okay. So this is just a main class in which we have at the Spring Boot application. So uh, you know uh, these are just application.properties in which I just added to interact with the database. Okay, so just at high level, so this is a just kind of a code walkthrough of my demo project. Okay, so now I'm just closing everything. Okay, so here if you see now, I will show you one by one. Okay, so first we will discuss about regular synchronous communication. Okay, so in a synchronous communication, so here if you see create employee is there, right? Okay, so just to minimize the time, I mean, I will just walk through the code. Okay, so if we do the coding line by line, it will take more time, so the video length will be more. Okay, so here if you see, so create employee is there, right? Here you can see I just accepted the request. I mean, here log statement you can see. So and um, here, okay, create employee here if you see in a synchronous way. So what I'm doing here, okay, I'm converting this model to entity. Model to entity in the sense, with the help of model mapper, I'm just converting this employee DTO to entity, employee entity, nothing fancy here. Okay. So and after that, what I'm doing, I'm saying, okay, I'm just setting the status as accepted and the status code as 202, and immediately I'm saving this particular employee entity into the database. Nothing fancy. Okay, and after that, okay, so let's assume, okay, this request takes some 15 seconds to perform some EPF calculations. For example, with which thread? Some thread I am printing. I want to know what is the thread name here. Okay, okay, let's assume, so I'm just sleeping the thread for 15 seconds. Okay, so let's assume in a real time we are doing some key logic to perform some EPF calculation. Okay, now I'm not going to do all those things. I'm just sleeping a thread to mimic that particular scenario. Okay, so let's assume after 15 seconds, our EPF calculations are all done. Okay, now we are having the results. Now I just set some hard coded values as some PF amount, or this is so and so is a PF amount, so and so is a pension amount. Okay, and after that, I just set the status as completed. Okay, and status code as 200. Okay, and and finally, I just logged the message saying that finally request processing finished with so and so thread. Okay, and and after that, finally I want to return this particular entity entity to model, and that model will be returned back to the user. Okay, so the same thing, I mean, whenever we try to create a new employee with some post call, what usually you do, you just have some employee payload in JSON format, and obviously it will take some 20 milliseconds or 30 milliseconds, and immediately it will return the response saying, boss, I have created your employee object successfully into the database, and this is the your created employee JSON, something like that, right? So now here what additionally we have done, I mean, initially we just set the status as accepted. Okay, and we just performed some EPF calculations by sleeping a thread with 15 seconds, and after that, we assumed that okay, our job is done, and we just set our PF results into this particular employee object. Okay, now here important point is I just annotated with this I mean with the transactional, so that's why here you can see I just I mean updated the values. Okay, and I didn't save this particular employee. Why? Because at the end of the execution, anyhow, transactional will take care of updating these values, and it will, even in the database also, it will update the record also. Okay, so this is what synchronous communication. So now let's see. I guess I already started the server. I guess. Okay, so let's see here. Okay, so let's clear the console. Okay, so here if you see. Okay, so this is the postman here, this is a endpoint. Okay, so here in my payload, I'm just passing, employee name is, and salary and city. Okay, now I'm just firing a request. Let's see what happens. Okay. Oh, okay. So it has thrown some, exception. Okay, it is saying that internal server given exceptions could not execute the statement. SQL nested exception is SQL grammar exception could not execute the statement. Okay, could not execute the statement. Okay, so here, Okay, so I guess server is started properly. One second, exception occurred with threads. Okay, table test.employee. See here, table test.employee does not exist. So so let me stop the server. Okay, let me stop the server, and let me start the server properly. See why? Because here in MySQL, this is the workbench. Here, if you see, if you just refresh, here so some time before I just dropped the table, so that's why since there are no tables, it is throwing the exception saying that a table does not exist or something like that, right? So now I just restarted the server once again freshly, so hopefully it will create the tables freshly to the database. See here, see it has create table employee, right? So it has created. Let's cross check even in the MySQL workbench. I'm just refreshing. See here, of course this donor table. I'm least bothered. Okay, just created like that. So just focus on this employee only. Okay, so okay, so yeah, application is started. Okay, now let's fire our request once again. Yeah. So here now if you see we are sleeping a thread for 15 seconds, right? See now I have to wait until 15 seconds, right? So this is a kind of synchronous communication. So there is no other way. It blocks our main thread. So for 15 seconds, see now 15 seconds are over. So now finally I can see, okay, it has created a employee record with ID 1. Okay, so on so values. Okay, equal source of PF amount, so on so pension amount. Okay, now the status has completed. Okay, and status code as 200. Okay, okay, let's verify the logger statements also for a better understanding. Okay, so here if you see accepted the request with a thread. Okay, what is the thread name here? HTTP neo 8080 exec-1, that means execution 1 or something like that. Okay, so where I added this log statement. Okay, so here if you see, this is the in the controller. Okay, this is the first line of our log statement, right? So here this is the within the controller, you can say this is the starting thread. This is neo 8080 execution 1. Now after that what happened, our flow is jumped to service class, right? Here, you know after saving our employee, again I am printing saying that, okay, this request takes 15 seconds for EPF calculation, right? So now here, where is that particular log statement? Okay, so here, yeah, you can see this request takes 15 seconds, right? So here you can see this is the same thread. Okay, HTTP new 8080 execution 1. Okay, here also you can see just now I have shown you. Okay, where it is. Um yeah, see this is the same thread, execution 1. Okay, and here you can see this is the execution 1, same thread. And after that it is the third log statement, finally request processing finished with the same thread. Okay, so that means what does it mean in synchronous communication? Whatever the thread we initiated at the controller, the same thread will execute the further layers also. The same thread will jump to here service class, and it will execute a whole this piece of code, you know, and finally it will come back to this controller. Okay, so that's why the client has to wait for until 15 seconds. So this is a synchronous way of communication. So right. So now we will discuss about asynchronous communication. So now in the asynchronous communication, what I'm doing here, if you see, okay, so here also I just logged the log statement saying that, okay, I accepted the request with thread. Okay, so now if you see, I'm just creating an employee. Okay, I'm just invoking this create employee. What I'm doing in this create employee, okay, I'm just okay, saving this particular employee entity into the database. What at all I'm saving? Before saving, I'm just setting the status as accepted and status code as 202. Okay, immediately I'm saving this particular employee into the database. I'm just returning this employee ID. See, this employee ID will be generated dynamically at with the auto increment kind of functionality in the database. So that's why I will get the dynamic value, and it will send back to the caller method. So now I will have the created employees employee ID, right? So now what I'm doing, now I need to perform some long running execution of EPF calculation, right? So that EPF calculation, okay, I just separated in a that piece of code in a one more exclusive other method. Okay, So for example, here if you see, to that particular method, I'm just passing this employee ID, right? So here now if you see, so here here, okay, in this method, I'm just adding one log statement saying that, okay, employee EPF calculations started with the thread or something like that. Okay, so uh, okay, so let's move this particular line to, okay, to here to make more sense. So here what I'm doing, okay, so with the help of this particular employee ID, now I'm just fetching that particular employee record from the database. Okay, so this is the employee, and after that, once we have employee, entity, now we can perform some EPF calculations on that particular employee entity. Okay, some key logic. So just to mimic the environment, again I'm sleeping a thread to 15 seconds here. Okay, so that's why I just added log statement. Okay, so after that, okay, just we are assuming that, okay, our whole calculation is done. Now I'm just setting the results with some hard coded values, and status as completed and status as 200. Here once again I'm saying I'm not saving this particular employee entity again to the database. Why? Because transactional will take care of that particular updation. Okay, so now so obviously whenever we fire this particular request, it will take 15 seconds, right? And it will take 15 seconds, and and after that, finally what I'm doing, I'm saying, okay, response entity dot status, okay, we have accepted your request. Okay, now your request may take, okay, let's change to 15 seconds. Okay, your request may take 15 seconds, and please check the response at so and so location. That so and so location is the same thing, v1 slash employees slash this employee ID. So this is a get call, right? So I have this get call, right? So the same endpoint I'm just specifying here. So after 15 seconds, you can happily click on this particular link, and you can see the results in the sense your PF amount or whatever, right? So now one question will arise. Okay, okay, we have separated this key logic, which takes more time, into one more separate method, right? But here, okay, don't you think still it invokes this entire execution in synchronous way only, right? Why? Because here, okay, so this particular line, it will create the employee record. Of course, you will get the employee ID. Okay, now you will pass that employee ID, and again in this particular method, again we are sleeping a thread to 15 seconds, right? So after 15 seconds only, the flow will come back to this particular line, and again finally it will say your request will take 15 seconds, right? It doesn't make any sense. So now what we need to do here, so what I said sometime before, the key benefit of asynchronous communication is client no need to wait until that whole long running execution finishes its job or whatever. Okay, so immediately the server will notify the client saying that we have accepted your request. So this is the status code toward to you, this is the response, right? So immediately it will send that type of response back to the client immediately. Okay, and of course in the background long running execution will continue, right? So now to achieve such type of functionality, now what we need to do here, we need to enable asynchronous mechanism here. So in order to enable asynchronous mechanism, as I said, we need to do two things. Number one. So the number one is here. So this is your main application, your main class in which we annotated with at the rate Spring Boot application. Okay. So here you can see we can add at the rate enable async. Okay, so this one, okay, this one we need to add. Okay, so this one either you can add here, or you can add to one more class which is annotated with at the rate configuration. There also you can add. Okay, so this is point number one. The second change what we need to do here. Okay, so here, okay, so this is a key logic, right, which takes a long time. So in our case 15 seconds. So this one we need to annotate with at the rate async. Yeah, we need to annotate with at the rate async method. Okay, so and two more important points is your method should be public. Okay, your method should be public, and if you don't want to, if you don't want to return the result back to the client, okay, then you can have a return type as void. Okay, so this is possibility number one, and the possibility number two is if you want to return the response back to the client, okay, some result. Okay, so then you need to wrap your result in either future or completable future. Okay, so then just return that particular future or completable future to the call method. Okay, So these are the two possibilities. Okay, now in our case, I am not returning anything, so this is kind of a void. Okay, so yeah, I just added the required two things, right? Okay, so that's it. Okay, now with the help of this async, now what happens? Okay, so immediately, okay, happily it will create a new employee record, it will get the employee id, and immediately, it will invoke this particular method. Now this piece of code will be executed in a brand new thread. Okay, so new thread, and it will continue the execution in the background. So that's why the main thread will not block until until this particular method returns the response, right? Immediately what happens, the flow will jump to this particular line, and immediately it will return the response back to the client. Okay, so let's see, is it happening like that or not? Okay, so one second, so let me see server is started properly or not. Okay, so before hitting, yeah, so I'm just clearing the console. Okay, I just added dev tool, so obviously whenever I do the code change, it will start the server automatically. Okay, so now, okay, yeah, I have a you know one more endpoint, so that is, see here, this is async, right? So that's why I just modified the endpoint. Okay, now I'm just you know kicking off this particular request. See, immediately I got the response. Okay, now I'm just clicking on this particular, this is the get call, right? Okay, I just fired a request. So here if you see, so here, see, this is accepted, right? Okay, again I'm clicking, see here, still it is accepted, again I'm clicking. Okay, so now this time, so now the third time 15 seconds are over, so that's why now I am able to see the results. Okay, so overall what I'm trying to say here, okay, so as soon as I click on this particular send button, okay, immediately what happened, the flow jumped to the controller, and immediately we have seen some response. Okay, so what is that some response? um so one second, yeah, so here, so we are able to see here, see 202 status, okay, accepted. Okay, and you will see happily it is saying that your request may take 15 seconds and please check the response at so and so location. Okay, so now client, client no need to wait, okay, until it finishes its long running execution. So this is the beauty of asynchronous communication, and we can continuously poll this particular link just by clicking on this particular link. Okay, so until 15 seconds it will return the results as accepted only, and this pf amount will be zero and pension amount will be zero. Okay, maybe third time or fourth time after 15 seconds, immediately we will be able to see the results. Okay, so this is the beauty of asynchronous communication. Okay, and one more point what I'm trying to say here. Now let's examine the log statements once again here. Okay, here you can say accepted the request which is there in the controller, execution one is there, right? Now execution one is there. Okay, yeah, so we are inserting the employee record, right? And that is in the first line. Now in the key logic, where is the key logic? See, this is the employee EPF calculation started, right? Here this is interesting. What is this one? Task hyphen one. So this task hyphen one, okay, this is a new thread. This is not a same thread which we have used in the controller, right? So this is this is a new thread, some task hyphen one. Okay, and after that finally, so it will print one more log statement, where that log statement, I'm not sure, am I printing or not? Okay, I guess I'm not printing, I guess. Yeah, I'm not printing. We have only two log statements. So okay, so now we have two threads. One thread is for controller execution, and the brand new thread is assigned to execute this piece of code. Okay, so this is one thing. Now, um, here the important point is, okay, whenever you add at the rate async, okay, so what happens? Okay, um, internally it will scan all configuration classes to search for thread pool task executor. Okay, do we have any thread pool task executor, the name as executor? So it will scan all the configuration classes. Okay, in case if it doesn't find, so then what happens, it will take the help of simple async task executor pool. Okay, so that's a default one. Okay, so then what happens, so that simple async task executor, it will it will initiate a new thread every time whenever you invoke this particular piece of method. Let's assume you are firing 500 requests to this particular controller endpoint. Okay, that 500 times the flow will jump to here, right? So since you added at the rate async, so it will initiate 500 new threads, okay, every time to execute this piece of code, which is not recommended, right? So if you in real time, obviously you will have thousands or lakhs of requests. So obviously the creation of thread is nothing but an expensive operation, right? So if you continuously create new thread, it's kind of a performance issue, right? So now to avoid such type of scenarios, we need to take the help of thread pools. Okay, so for the thread pools, what we need to do? Okay, so here if you see, this is my configuration, right? So this is configuration. So here, okay, let me uncomment this particular piece of code. Okay, so here, okay, see, I have one thread pool task executor. Okay, of course, you can see core pool size as 2. Okay, and maximum pool size, okay, let me have some 20. Okay, reasonable value. Okay, and after that, okay, so this is to just to shut down. Okay, the name I am just giving my thread pool name as async hyphen something. Okay, and here you can also have some queuing capacity also. So I mean, so queuing capacity in the sense, I mean, as soon as your requests continuously pop up, okay, so then your jobs will be continuously added to the some blocking queue. Okay, so you know. So your core pool size, these two threads will continuously handle your request. Okay, so for example, if your queue capacity is 100, so if all 100 jobs are already added to the queue, so then obviously two threads are not sufficient to handle 100 jobs, right? So then it will kick off the remaining 18 threads, then that your pool size will become 20, from 2 to 20. So then the 20 threads will handle your 100 jobs. Okay, so let's assume 20 threads are continuously working for 100 jobs. Now one not one request entered. Okay, then it will reject the particular request, saying that, oh, we are totally engaged. I'm sorry, so just wait or something like that. It will reject. So this is just a kind of thread pooling mechanism. I just explained like that. Okay. So now what I'm trying to say is, okay, now I just uncommented this particular one, so I didn't mention any name. So task executor is my method name, right? So then what happens? As I said, okay, now we have a proper thread pool task executor, right? So then if you see now, okay, if I execute the same code once again, so let me confirm once again. Uh, so here, yeah, it's starting. Will take a while. Yeah, it will take a while. Bear with me. Yeah, let's see by firing a request once again. Okay, so I'm just closing this. Okay, so now once again I'm firing a request. Yeah, I'm firing a immediately got the response. Okay, so now I'm just hitting this particular one. Okay, so here you can see accepted. Okay, second time I'm triggering. Okay, now this time also accepted. Okay, third time I'm triggering. This time also accepted. Fourth time I'm triggering. This time completed. Okay, 15 seconds are over. Okay, now let's examine the results. So here you can see see accepted the request execution one. Okay, this is at the controller level, right? So now here you can see, so this time see, it has activated the thread pool. So that's what I'm keep on saying. So async hyphen one, last time, did you remember that thread name was task hyphen one? Now this is async hyphen one. Okay, async hyphen one. Okay, so here you may ask one question saying that, okay, so here, okay, in the entry testing, we didn't pass any task executor pool name, right? Here we have simply at the testing only, right? So the answer for that question is, okay, so if you have a method name with a task executor, so you no need to append that particular name to at the testing. So this is one observation. Okay, the second observation is, Okay, for example, here you can give a different name. Okay, for example, here you can give pool task executor. Okay, for example, now I just changed a different name. Okay, now this time what you need to do, you need to give your bean name as a task executor. Okay, bean name as a task executor. Okay, so this time I just modified the method name, but the bean name is task executor. So then what happens? Okay, it will okay, it will scan this. Okay, it will identify, okay, this thread pool task executor is nothing but it is having a bean with the name task executor. So so then also it will work the same thing, uh, like how it has executed just now. Okay, so let's see. So yeah, let's come here. I'm just closing this. Yeah, yeah, so immediately got the link. Okay, I'm just filing a request once again. Okay, so here you can see accepted. Okay, here you can see accepted. Here third time accepted. Oh, see now, oh, still accepted. Okay, this time. Okay, so here you can see this time completed. Okay, so now let's see the results here. So here if you see this is execution one. Here you can see this is async one. Okay, async one. So that's what I'm trying to say now. Okay, the third possibility is, okay, I have given a different method name. Here also I have given it the different method name. Okay, so for example, saying that thread pool. Okay, thread pool task executor. Okay, so for example, I have given a name something like this. Okay, thread pool task executor. Okay, so now, since our my method name doesn't match the expected name as task executor, and even bean name is also not matching with the task executor. Totally, I have given different names, right? Now this time, okay, this time we need to annotate, or this particular method with @async. In here, you need to pass that pool name, the same pool name, whatever you have given. Okay, so this time what happens? Otherwise it won't work. Otherwise what happens, it will consider the default simple async task executor. Okay, so here if you see, yeah, it will take a while to start. So meanwhile I will close this particular one. Yeah, so hopefully the server has restarted. Let me fire a request. Okay, yeah, so here you can see I'm just firing a request. Okay, get call. Okay, I accepted. Okay, here I accepted. Third time I accepted. Fourth time I accepted. Fifth time I accepted. Sixth time also accepted. Okay, so here, yes, now this is completed. Okay, so now let's examine the results. Okay, so here you can see, so this time also, yeah, so here you can see async one. So these are the three possibilities. Now I hope you guys understood like how to define the thread pool. So when we need to pass this type of pool name to this @async annotation, and when it is optional. So I just explained till now. Okay. So now I want to cover one more concept, saying that um, so now we have core pool size as 2, right? Okay. Now let me continuously file the request once again. Okay. So just now you have seen async one, right? Okay, so here I want to show you. Okay, so here, okay, let's say once again I filed a request. Okay, so yeah, I don't want to click on this particular one. Okay, so here I just want to show you the logs. Okay, so here see now this time async hyphen 2. So that means what I'm trying to say is now we have a core pool size of 2, right? So very first time, okay, it has utilized the async hyphen 1. That is the first thread. Okay, now say for the second request, it is utilizing the async hyphen 2. And even for third request, whichever thread is free out of async 1 and async 2, whichever is free, and it will serve the third request. Similarly, fourth request, fifth request, or something like that. Overall, these two threads only will serve all your subsequent requests until your queue is full or something like that, right? Okay, so this is fine. Okay, now finally I want to cover the final concept. Okay, saying that, okay, that concept is what happens if we have few exceptions within our async method execution. Okay, so this is async method execution, right? Okay. uh, okay, so for example, what I'm doing, employee, intentionally I'm pointing to null. Okay, so this time what happens? Okay, uh, obviously it will throw null pointer exception, right? So here, yeah, it's restarting, it will take a while. Let me hit. Okay, so we got some response. Now see the console. See the console. Now you will find that null pointer exception after 15 seconds. Why here after thread dot sleep only you just pointed to null right here. See, we have got some exception saying that null pointer exception null. Okay, and this is the entire exception stack trace. Okay, here you can see unexpected exception occurred invoking the async method so and so method. So now how to customize this particular error response? Now you want to give your own statement, right? Whenever any exception occurs, and let's assume you are having this type of 10 async methods, and whenever any exception occurs in any asynchronous method, you want to see that particular method name and class name properly, right? So then how to handle in the sense? Okay, so for example here we have an global exception handler, right? So did you remember? Okay, in the case of Spring REST applications, we have global exception handler. So if, any type of exception occurs, so obviously it will come to this particular method, right? So, but see, I just started on my server in debug mode only, but flow didn't come to this particular point, right? Flow didn't come to this particular point. So then how to handle that particular exception is, so there are, uh, so we need to do some steps. Okay, what we need to do? So first we need to create one exception handler. Okay, why? Because here our global exception handler, I mean, didn't work as expected, right? So there is a one more separate methodology to handle the asynchronous communication. So what we need to do? Okay, so go to exception package. Okay, so I'm just adding this particular one. Okay, so here you can see async exception handler. Yeah, I just added this one. Okay, and after that we need to create one separate configuration class. In that configuration class, okay, go here, config package. Okay, I just added here. Okay, I'm just extending this async configurer supporter. So there we have one override method, so we need to override this particular method. So in that one I'm just saying return async exception handler. What is this async exception handler? So just now I have created, right? So here I'm just handling the exception. So this is my own customized statement. So from now onwards it will print the method name, class name. Here you can see, and the exception status, and it will print something like this: unexpected asynchronous exception or something like that, right? So yeah, so let's hit the same request once again. So hopefully server is started. So let me hit once again the same request. Yeah, we got the response. Now here if you see, um, um started, one second. Yeah, yeah, here you can see this is your own customized statement: unexpected exception occurred invoking async method. Okay, see, this is same statement. Here you can see an unexpected asynchronous exception at. Okay. mm, Asynchronous exception. Oh, one second. Unexpected asynchronous exception occurred invoking async method. Not. Oh, this is the world only. Okay. Yeah. So now server is started. Okay. Now I need to hit. Okay. So yeah. So before server the startup only, I just did a hit. Okay. It's my mistake. Okay. So now let's see the results once again. So yeah, so after 15 seconds it will throw that particular exception. So why? Because I mean I'm just pointing to null after 15 seconds. Here you can see. So I guess, yeah, see, here you can see after 15 seconds only I'm pointing to null. So yeah, see now here you can see, yeah, see now it is completely matching. So here if you see, this is my async exception handler. See now unexpected asynchronous exception yet. So here also you can see unexpected asynchronous exception yet and so and so class, so and so method name properly it handle. This is the exception stack trace. So like this we can handle the exceptions in asynchronous mechanism. Okay, yeah, so yeah, so this is a okay, no, coding part. So now let's jump into our uh, yeah, our slide. So till now, till here we already discussed it, right, how to enable. So now this is the key points to remember. Okay, so so here if you see at thread async annotation must be on the public method. Okay, so here how transactions work, so based on some proxy concept, right? So you need to always invoke those transactional methods from the previous layer, right? So then only it will invoke on the proxied object. So by that way your transaction will be triggered, and in a similar way the same concept will be applicable to async methods also. So here you can see Spring use a proxy for the annotation and it must be public for the proxy to work. Okay. So in case if you try to invoke your async method within the same class, it doesn't work. Okay. It doesn't initiate in a new thread. Okay. This is a very important point. Okay. And similarly, method with the return type should be always wrapped with a completable feature or future. Okay. Now Spring tries to find a thread pool which is associated with the context. It uses this thread pool to submit the request in a separate thread and release the main thread. Okay. So here this is an important point. Spring will search for task executor bean or a bean named as task executor. So otherwise, if it doesn't find, then it will fall back to the simple async task executor, which creates a new thread for every invocation. Okay, so this is important point that I already shown now. No? So yeah, so that's why it is highly recommended to configure the thread pool to perform the async methods instead of a simple async task executor. So which initiates a new thread every time. So we don't want to initiate a new thread every time, right? So that's why we need to configure the thread pool task executor. So these are the three possibilities. Just now I already explained, right? So these are the three possibilities. Okay. So either you need to, your method should be annotated with, sorry, method name should be task executor, or the second possibility is if your method name is a different name, so then at least your bean name should be task executor. Yeah, the third possibility is your method name is different, method bean name is different, then that new bean name, then in that case only you need to add that bean name to @async. Okay, otherwise the remaining cases you can have only @async. Okay. So how to attach a thread pool in the sense, so this is a sample piece of code. So we need to define thread pool task executor, something like this. Core pool size, max pool size, queue capacity. I already discussed all these concepts. Okay, so this is a just a the same concept what I already discussed. I mean, what is the mechanism of core pool size, max pool size, queue capacity. Okay, so how to handle the exceptions in async method? As I said, first we need to write a exception handler which implements async concat exception handler. Here you need to add your customized log statement. Okay, now this async exception handler you need to point in the async configuration class. So which extends async configure support. So here we are overwriting the the default exception handler with your own async exception handler, right? Yeah. So this is end-to-end discussion about asynchronous communication in Spring Boot. I hope you guys understood the asynchronous concept. Okay, so if you really like my video, please like and share and subscribe to my channel. Thank you.